divide over here on the left. So I'm dividing by x squared minus x, and I'm dividing the polynomial x to the fourth minus x to the third plus 4x squared minus 4x. So let's begin. Now, it might be helpful, right, to remind yourself what division of polynomials is asking us to do, what our goal is. And to really think about it, go back to your original setup here. We're searching for the two factors that when we multiply with the other two factors will give us our original equation, our original function in full unfactored form. So I'm looking for the factors which when I multiply by x squared minus x will give me x to the fourth minus x to the third plus 4x squared minus 4x. So let's think about it. What factor will we need to multiply x squared by to get x to the fourth? And that should be pretty clear. I'm going to need to multiply by x squared. X squared times x squared will give me exactly what I'm looking for, x to the fourth power. And then remember the distributive property, because I'm going to have to multiply this first term by both these terms, I multiply also by negative x, and I get negative x cubed. Should have done that all in one color. All right, and so now I'm going to subtract what I've gotten. Remember, because now I know that when I multiply by my first term, I'm going to get the x to the fourth, and I'm lucky I also get the x to the third. So I no longer need to worry about these two terms, and it turns out all I'm going to care about finding now is what I can multiply, what other term can I multiply by x squared minus x to get what's left over. So I will subtract what I've already gotten. I distribute that negative sign in, so be very careful that you show your work here. This becomes a negative x to the fourth and a positive x to the third, and so x to the fourth minus x to the fourth cancels, negative x to the third plus x to the third cancels as well, and all I'm left with is 4x squared minus 4x. And so I will divide once again, and I will think about, okay, now this next term, when I multiply, I need to get 4x squared minus 4x. Well, what will give me 4x squared? Multiplying by a positive 4. So I multiply by 4, I will get 4x squared minus 4x. Once again, notice I've gotten exactly what I had hoped, right? So I will subtract away what I'm now getting. Again, this 4 times x squared minus x will give me the 4x squared minus 4x, which is exactly what I had left. So when I subtract away what I've gotten, I'm going to have a negative and a positive, and these will cancel and these will cancel, so I'll be left with no remainder. So at this point, pause, think about what you've just found in relation to what we were searching for, and then come back and we'll talk. All right, so this is the missing factors, right? We went ahead and we divided, and what we got was x squared plus 4. So we divided and we got x squared plus 4. Those are the missing factors. We'll call them P and Q, right? The two missing factors that I originally was looking for. And you'll wonder, well, I have one factor. Why, where are the two? Remember, we're looking for linear factors. This is a quadratic. How many linear factors will a quadratic have? It will have 2. So what we need to do is we need to go ahead and factor x squared plus 4. So if you think about factoring it, there are a couple ways. You could just go ahead and factor by reverse foiling, thinking about your first term and your last term and then what the inner term has to be. Or you can also think about, how do we find factors again? Remember, factors and roots are linked, so if we can find the roots to this equation, this expression, x squared plus 4, what makes it 0, we will know both of the factors. So I'm actually going to use that method, and I'm going to think about, and I'll do this again off to the side, I'm going to think about what will make x squared plus 4 equal to 0. Now, two ways to find this. This is a quadratic equation. You're setting it equal to 0. What are the solutions for x? Quadratic formula will get you there. You may also just solve for x because there's no x to the first term. So I can solve for x squared by subtracting 4 on both sides and then square rooting both sides, and I'll get x equals plus or minus, because remember, a squared, it doesn't care if it's positive or negative, it'll give you the same answer, plus or minus square root of negative 4, which of course is an imaginary number. It is an imaginary root. So I will have plus or minus, the square root of 4 is 2, and it's imaginary I, plus or minus 2i. So my factors are going to be x. Now think about it. If your first root is plus 2i, well, you'll need minus 2i so that it goes to 0, and your other factor will be x plus 2i. So the two factors that you were missing were exactly P and Q, are x minus 2i and x plus 2i. So now we have the whole set of factors that we were looking for, and we can rewrite f of x. Our function, f of x, is just our first factor, x minus 1, times our second factor, x, times our third factor, x minus 2i, times our last factor, x plus 2i. Okay? Now at this point, I want you to consider what we were trying to do in the first place, which was to find the roots and then ultimately to graph our function. So go ahead and try that now, and then when you've tried it a couple of times, come back and we'll take a look. Alright, so considering how we'll graph this function, we want to think about what is the basic shape, what are the roots, and then are there any, what happens at the roots? Is it passing through the x-axis, or is it bouncing off the x-axis, or is it even hitting the x-axis at all? So the basic shape of our function, this is a fourth degree polynomial. So it will have, and it's got a positive leading coefficient. So it will look like this. The end behavior on both sides will be moving upwards. And we know that there are roots when x is 1 and when x is 0. Those are real numbers that are on our x-axis. However, these are imaginary roots, so they won't show up on the x-axis. So we're not going to be able to express those in our graph. All right? However, at both of these roots, right, notice that at each of these roots, our function is going to pass through the x-axis. So at this point, go ahead and try and graph your function. All right, so now we're going to try and graph our function, and we'll plot each of our roots. So when x is 1, we have a root, and when x is 0, we have a root. We know that it's positive going to the left, so it will cross through at 0. It will then cross through again at 1, and then must go positive again. These two imaginary roots, they're imaginary numbers, so we can't plot them on our x, y coordinate plane. However, they are values that will make our function equal to 0, and so they are important, but they don't show up as touching the x-axis. So it is important to remember that roots don't necessarily mean that we're always going to hit the x-axis 4 times. It does mean, however, that there are 4 values. They might be complex, they might be real. Either way, they're going to make our function equal to 0.